Okay, our final topic for chapter 4.1 is the area of a sector of a circle. A sector of a circle is the region bounded by two radii of the circle and their intercepted arc. What in the world does that mean? Well, here I have a circle, and here I have two radii, all right? And the area of the region that bounds them, we could consider this area here in blue, all right? And their intercepted arc of an angle theta right here. Okay, so for a circle with radius r, the area A of a sector of the circle with central angle theta is given by area is equal to 1/2 r squared theta. Now, key thing, keep in mind, again, theta should always be measured in radians. Theta must be measured in radians in order to use this equation. So, for example, find the area of a sector of a circle with a radius of 3 meters and a central angle of 225 degrees. Well, here we are given our angle measure in degrees. In order to use our new area formula, we must convert it to radians. We do this by multiplying by our conversion factor, pi radians over 180 degrees. Notice we get 225 degrees divided by 180 degrees. Degrees are going to cancel out. And 225 divided by 180, well, that reduces into 5 over 4 times pi. This is 5 pi over 4 radians. So to calculate our area, all we have to do is now use our formula. Area is equal to 1/2 times 3 meters squared times 5 pi over 4. That is our angle measure in radians. Now notice that I included the units of our radius here because that will actually remind us of our units for our final answer. We're finding area. If we have meters and we square that, our unit for our final answer should be meters squared. So multiplying all of this together, again, this is going to give us 45 pi over 8 meters squared. I recommend multiplying out all the numbers, the numerical values here, and keep it written in terms of pi for your exact answer. If then you want to plug in pi to get a decimal approximation and a better understanding of that value, that's fine. But again, know that I'm looking for exact answers. All right, this is approximately 17.7 meters squared. Let's try another one here, a little bit more challenging. A car's rear windshield wiper rotates 125 degrees. The total length of the wiper is 25 inches. The length of the blade that wipes the water away is 14 inches. Find the area of the region covered by the wiper blade. Okay, so here we have our total wiper length, and then the blade on the end is 14 inches. It sweeps back and forth through an angle of 125 degrees. All right, so if we want to find the area of this region in here, notice that we actually are dealing with two sectors. And to do that, we could take the area of our large sector, that would be this whole region here, and subtract the area of our small sector here. That would give us this yellow region, which is the region that the water gets wiped away from. All right, so let's use our area formula. Remember that area is equal to 1/2 r squared theta, where theta is measured in radians. Well, here we have our angle measure, and what do you know? It's given to us in degrees. So we're going to have to convert that. Oh, one other thing to make note of is that if we're going to find the area of this blue sector, we need to know the radius of the arc here that we sweep through. And to find that, we would take 25 and subtract 14. 25 minus 14, that gives us 11 inches for the radius of this smaller sector. So we have theta is equal to 125 degrees. We're going to multiply that by pi radians over 180 degrees. We start off by dealing with these integers. 125 divided by 180, plug that into your calculator, hit enter, hit math frac. That gives us 25 over 36. That's 25 pi over 36 radians. Again, we want exact answers. So our area is going to equal 1/2 times 25 squared, that's our large radius, squared, times theta, minus 1/2 times 11 squared, that's our small radius squared, times theta. All right, and one thing to make note of that might make this calculation a little bit easier is that each one of these terms here has a 1/2 times 25 pi over 36. And so what I'm actually going to do is I'm going to factor that out from each of those values. I can bring it to the front. I have 1/2 times 25 pi over 6 times the quantity 25 squared minus 11 squared. Okay, I just factored out a 1/2 and the 25 pi over 36 from each of those quantities. That's going to make my life a little bit easier in doing my calculation. I can now begin to plug this into our calculator. Remember, leave the pi's towards the end, all right? That should be the last thing. So deal with all of your integer values first, and then multiply by pi at the end. Doing so gives us 170 pi inches squared, or approximately 549.8 inches squared. All right, there you have it, area of a sector of a circle. Make sure you guys are comfortable with your calculators. If you have any questions on how we are getting these numbers by plugging into our calculator, make sure you reach out and ask for help. There you have it. That's the end of section 4.1.